Hello everybody and welcome back to Algebra 2. Today we're going to be talking about 3-2, solving systems algebraically. Let's begin. First things first, let's talk about a little bit of vocabulary, but more importantly, let's talk about the review. Can you circle the equations that are in standard form? Well, remember, in order for something to be in standard form, it needs to be in the ax plus by equals c form. All right? If it doesn't look like this, then it's not obviously in standard form. So taking a look at the very first one, we know that we have the 4x plus 3y equals 2. I would say that that is in fact in standard form, so we will be circling that. However, the y equals mx plus b form, which we see of the y equals 3x minus 5 portion, we know that that is not going to be correct. We have the 4x minus 3 equals 2y. Now this is very, very close, because we do have that 4x and we do have a 2y that are separated, but again, they're not on the same side of the equal sign, and more importantly, the number by itself, that -3, the constant, is going to be attached with that x, and that can't be done, so we know we can eliminate that. And the very last one, the 2x plus 5y equals 0. 0 is still a number, so we can consider that to be the c value, and you do get ax plus by. Therefore, the first and the last portion will be correct. All right, write each equation in standard form. Again, it needs to be the ax plus by equals c form. So we need to make sure that we put the ax and the by on the same side. In other words, we need to make sure that the x variable and the y variable are on the same exact side. So there are some people that battle back and forth between whether or not the x variable needs to make sure that it stays positive or not. More importantly, the coefficient to the x variable needs to stay positive or not. And in this case, we're going to just try and keep it positive. So I'm going to actually subtract the y to the other side. But in doing so, I'm also going to add the 3 to the opposite side as well. All right, this will cancel out the y's, and we're going to be left with a positive 3 is going to equal a 5x minus y. And if we were to rewrite that backwards, you would get 5x minus y equals 3. Now, if we just subtracted the 5x over, we would get 5x plus y is going to equal a -3. And in order for us to get rid of the negative, we would change out everything by dividing by a -1, hence why the opposites of all of the signs seem to happen. The -5x becomes a positive 5x, the positive y becomes a -y, and the -3 becomes a positive 3. Again, keeping the coefficient of the x positive, I'm going to just simply subtract the y value to the other side, and you'll get that 6x minus y is going to equal a -4. And finally, we're going to try and figure out how to rewrite this one. We're going to add that 12 to both sides. And it's already done for us. We have a 3x minus y is going to equal a positive 12. Great work. So paying attention to the vocab today, we're going to be talking about solution. So if two numbers are substituted for x and y in a system of equations, and they both make the equations true, then the ordered pair xy is the solution to the system. So a solution is any ordered pair that makes an equation in variables true. So if I had to write three ordered pairs of the solution to the equation -5x minus 2, I'm just going to start by plugging in the x values. So the very first x value I'm going to plug in will be a 0. So I would get -5 times 0 minus 2. And then if I solve it out, you know your y value. So we got -5 times 0 is 0, minus 2 equals y, so we get a -2, because 0 minus 2 equals -2. The next one I'm going to choose is a -5. Again, I'm going to get y is going to equal a -5 times a -5, because I'm just plugging in the -5 for the x value, minus 2. So we get y is going to equal 25, because negative times a negative creates a positive. 5 times 5 is 25. And then you're going to subtract 2 from that, meaning y is going to equal 25 minus 2, which means it's going to be 23. And the last one I'm going to choose is 5. If I were to change this from a -5 to a +5, I'm going to change that positive 25 to a -25. And you get -25 minus 2, which will give us a -27. Use the system on the right to write T for true or F for false. Well, paying attention to this system that we have right here, I'm going to type it in Desmos. I'm going to get these two lines right here where the red line represents the 2x plus y over 2 equals 3, and the blue line represents the 4x plus y equals 2. Using that information, can we decide what is true or false? Well, question number 6, the system has a unique solution. Unique solution meaning that it has one solution. And in this case, these are parallel lines. There will not be a single solution, and therefore that is going to be considered false. The system has infinitely many solutions. Again, these are parallels, so if it was infinitely many, that means that no matter what we plug in, it's guaranteed to work, which also represents the same line. And in this case, this is clearly not the same line. The two different lines are parallel, therefore this one's also going to be false. However, the system has no solution is going to be true because that represents parallel lines. And that's exactly what we have. Now the solution is 0, 0. Well, if we didn't have a unique solution and we didn't have infinitely many solutions, then we can't have a solution that is 0, 0. Therefore, this is going to be false. And last but not least, the solution of a system can be found by graphing the equations of the system. And I mean, yeah, that is absolutely true. Paying attention to what the graph looks like, we can decide whether or not it has a solution. In order for this to have a solution, we would have to just basically change it up and give it a different slope than the previous equation. So if I had like a slope of, well, 1, you'll see that the solution is where they cross, which means that the solution is going to be at the point 1.33 repeated, and the y value is going to be 0.6 repeated. It gives you the solution. So graphing can absolutely be used to figure out the solution like we did before. Great work. Problem 1, solving by substitution. What is the solution to these two systems? Part 11, follow the steps to find the solution. Solve the first equation for x. In other words, if we have x plus 3y equals 5 and we want to get x by itself, I'm going to subtract the 3y to the other side. This will cancel out these 3y's and leaving us with a 5 plus a negative 3y, or a negative 3y plus 5. Once we know what x equals, we can then just plug it in for wherever we find the value of x. So again, this is just going to be plugged in for that x. So instead of it being negative 2 times x, it becomes negative 2 times negative 3y plus 5. And then we're going to subtract 4y, and now we just have to distribute. Negative 2 times that negative 3y, and then negative 2 times the positive 5. And you'll get a positive 6y, negative times a negative, 2 times 3, right? And then you'll also get a negative 2 times a positive 5, which will give you that negative 10. So we now are looking at 6y minus 10 minus 4y is going to equal a negative 5. But we're trying to solve for y. So if we try and figure out this by solving for y, we need to combine like terms. I see a like term right here with the 6y and the negative 4y. So if I were to combine both of those, you'll get 2y is going to be subtracted by 10. And it doesn't really show it right here. I think it was a little bit of a typo, but we should get 2y minus 10. And that is going to equal negative 5. But they also added the 10 to the other side, and that is a reasoning for the positive 5 on the right-hand side. So they did add the 10 over. It's not an actual true typo, but they just skipped over this step. All right, so now we have 2y equals 5. We're going to divide by 2, and you'll get that y is going to equal roughly 2.5. Knowing that same exact answer, we can then plug and substitute that value into the y value. So now we have x plus 3 times 2.5, because that's what we know y equals, which would be x plus 7.5 equals 5. We subtract the 7.5 from both sides, and you'll get x is going to equal a negative 2.5, meaning that the solution of this system is going to be at the point negative 2.5, comma 2.5. Problem number 2, using substitution to solve a problem. An online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes a one-time registration fee. What is the cost of each download and the registration fee? Complete the model to write a system of equations. The total cost is number of downloads times the cost of one download plus the registration fee. So if we let C equal the cost of one download and let R equal the registration fee, we can then create two different actual equations, creating a kind of system. So again, our very first one represented $19.75 because that is our total cost of buying 15 downloads at a certain price. So I know it's going to be a 15 right there. And the next one is going to be $43.50. And it's going to be 40, because that's how many downloads we have, times our C value once more, plus our registration fee, which is that R. All right, so the major difference between the two is that we have a 15C is now 40C in the more expensive version, and obviously the price at the end is also a major difference. So let's take a look at part 14. Circle the equation that represents R in terms of C in the first equation. Now the first equation was $19.75 equals 15C plus R. So it was going to be $19.75 equals 15C plus R. So if I were to subtract the 15C over to the other side, you'll have a negative 15C, that's the very first part, and we would have a positive 19.75. Well, this does have the negative 15C, but it doesn't have a positive 19.75. This is not even a negative 15C, so it clearly has to be the first choice. Substitute the equation you choose in the exercise 14 into the second equation of the system and solve for C. So let's just plug it in. So we know that the number next to the C value is going to be that negative 15, and we know that that number by itself will be the $19.50, so we just plug it straight in. Now notice, this R is what we changed to the negative 15C plus the 1975. Combine like terms, 40 minus 15 will give us 25C. We're going to subtract the 1975 from both sides, which will give you $23.75 is going to equal 25C. Divide both sides by 25, and you'll get around 0.95 is going to equal your C value. Now substitute the C into the equation to solve for R. I'm going to just use the original equation that we know R equals. It's A-okay to do. So I'm going to now have R is going to equal negative 15C plus 19.75, but I'm going to take that C value and I'm going to plug that in with parentheses as shown, and I'm going to be able to multiply everything down, and you'll find that eventually R will equal 5.5. So the cost of each download is going to be around 95 cents, and the registration fee is $5.50. Problem number 3. Solving by elimination. Well, if you don't really like solving by substitution, we can always solve by elimination. And it's exactly as it sounds. So what is the solution to the system of equations? And we see it right here. Well, if we wanted to do the solving by elimination, we're going to literally eliminate one of these two variables, whether the x variable or the y variable. In order for us to do that, we actually have to add these two equations together. But in order for us to be able to eliminate something, we have to be able to add these equations together if the variable has its equal but opposite counterpart, meaning one coefficient needs to be the positive form of the negative coefficient on the other side. The best way to look at it is right here. This is the equal but opposite coefficient. We have a positive 8y and a negative 8y. They're equal in value because both of them are 8. However, they're opposites because one's negative, the other one's positive. So if I were to add these straight down, you'll get negative 2x plus 5x, which is going to give you 3x. But right here, this 8y minus 8y is going to cancel out, leaving you just with 0y. And same thing for the very last little bit. We have that negative 8 and the 20, so we add those together and you get a positive 12, because 20 minus 8 will give you 12. Now taking a look at this portion right here, since that 0y is gone, I can actually divide both sides by 3, and you'll end up with that x is going to equal 12 divided by 3, which is 4, because we simplified it down. Now, if we know that, we can choose any of the original equations, and more importantly, we have to choose the original equation. So I'm going to choose whichever one I find is easier than the other, so I'm probably going to be using, personally, that 5x minus 8y, because I don't feel like dividing or multiplying by a negative number. In this case, that negative 2x would be something that I have to multiply straight up. So me personally, I'm going to plug it into the 5. So I'll get a 5 times 4 minus 8y is going to equal a 20. I then get 20 minus 8y equals 20. I'm going to subtract 20 from both sides, and you'll get a negative 8y is going to equal 0. Divide both sides by negative 8, and you'll find that y is going to equal 0. Now, as you can see in the bottom portion, we do have a point for 0, which is going to be given right there. So this is going to be the correct answer. But just to prove that it does not matter which one of these equations that you choose, it just needs to be an original equation, I chose the bottom portion. Pearson chose the top. So when they plugged it in, they plugged the x next to the negative 2. So we get a negative 2 times 4 plus 8y, and then they solved it out the exact same way. They got the exact same answer. So it doesn't matter which one you plug it into, you just have to choose one of the originals to do. And both of them gave us the solution answer, which is going to be that 4, 0. Problem number 4, solving an equivalent system. What is the solution of the system of equations? Underline the correct values to complete the sentence. To get additive inverse with the x term, you must first multiply the first equation by some sort of number. Well, if we want to figure out the x term needs to be its additive inverse, which means that we need to get this 3x and 5x to be equal but opposites of one another. So we're going to multiply the first one by the 5. So if we multiply that top portion by 5, we are going to get a 15x plus a 35y is going to have to equal 5 times that 15, because we're just distributing out everything. And 5 times 15 is going to be 75. So in order for us to make sure that we get the equal but opposite value of the coefficient for the x value, we have to turn that 5x into a negative 15x. So in order for us to do that, we have to multiply the bottom portion by a negative 3. And if you were to do that, you get a negative 15x minus 6y is going to equal 12. More importantly, a positive 12. So we have to figure out the brand new additive inverse term based off of the system of equation that we just created, which is going to have the 15x plus 35y, which the only one that has that is the final one, but it also has the negative 15x minus 6y, again equaling the 75 for the top equation and 12 for the bottom equation. Solve for y. Well, if we were to add these straight down, we can eliminate them right off the get-go, and you get 29y is going to equal 87. If we divide both sides by 29, you'll get that y is going to equal 3. And now that we know y equals 3, we could just plug that into one of the original equations, whether it's going to be the 3x plus 7y equals 15, or the 5x plus 2y equals negative 4. It just needs to be the original equation. More importantly, before we start multiplying by that 5 or the negative 3. So one of the original, true original ones. So I'm going to use the 5x plus 2y equals negative 4. So I'm going to plug that 3 into the y value, giving you 5x plus 6 equals negative 4. If I were to subtract the 6 to both sides, that's where that negative 10 comes from, and minus 6 from both sides. Right? Because 2 times 3 is a positive 6, subtract it over, and you get 5x is going to equal a negative 10. We then are going to divide by 5, and you'll get x is going to equal negative 2. So our solution is now going to become our y value being 3 and our x value being a negative 2, so it becomes negative 2, 3. Problem number 5, solving systems without unique solutions. What is the solution of the system of equations, and explain. Circle the first step to solving the system. Well, if we're trying to find its additive inverse, we have to either multiply the top or the bottom by a certain number to get it so that we have the alternate equal portion. So in order for me to do that, I'm going to probably multiply the top portion by 2. And the reason I'm going to multiply the negative x plus y equals negative 2 by 2 is because if I were to multiply this portion by 2, it will change everything to a negative 2x plus a 2y, and it's going to equal a negative 4. But at this moment in time, I see that we have the additive inverse with the x's values as well as the y values. So if we had to add both of these straight down, you'll find out we get in 0x, and then we also get plus a 0y, which means that we're going to get 0 on the left-hand side, and negative 4 plus 0 is going to be negative 4. Well, what is the solution to this system? If 0 equals negative 4, that doesn't make sense. And since it doesn't make sense, there is going to be no solution. These lines are going to be parallel. And if there are no solutions, that means that there are not infinitely many solutions. If this was infinitely many solutions, we would get it. The end answer would be something like 0 equals 0 or 2 equals 2. Both of these make sense, and they will always make sense, and that's where you get the infinitely many. But 0 equals negative 4 makes no sense, and that's why it's considered no solution. And we finally made it, the lesson check. Let's get going through this last little bit. And obviously, as you can see, it's very, very short. So let's finish it off quick. Question 29. Cross out the system of equations that is not equivalent to the others. So the very first thing I'm going to do is I'm going to figure out and solve each and every one of these and see what I get. So looking at the 4y and the 4y, I know if I change one of these to a negative form, so multiply by negative 1, we can then eliminate out everything. So this will become a negative 4y plus x is going to equal a negative 3. If we were to add straight down and not pay attention to this portion, you'll get that we have the 4y's will cancel out, and then we get a 5x plus x gives you 6x, and that's going to equal 10. So we can divide that by 6. You'll get x is going to equal 10 over 6. And knowing that information, let's see if we can actually just go through and solve the rest of it out and make sure that we don't get anything that matches up. And I'm just going to solve for the x value, because in order for that to happen, our x value would all have to be the same, right? So if I were to multiply this one by a negative 4 up top, this way I get rid of the y's and I can immediately solve for just the x. If I multiply that by a negative 4 straight off the get-go, we're going to be given a negative 4y minus a 20x is going to equal a negative 48. Alright, and if I were to add those straight down, these will cancel out, and I'm going to be left with a negative x minus 20x, which gives you a negative 21x, and that is going to equal a negative 48 plus 3, which is a negative 45. And then I'm going to divide everything by negative 21. And you'll get that x is going to equal positive 15 over 7. Which, as of right now, these don't match. So it comes down to the final one. So if I'm going to multiply the bottom portion by that negative once more, negative 1, that will allow us to give you a negative 8y plus 2x minus 6, which is going to give you these canceling out, a 42x is going to equal a 90, and then we divide both sides by 42, and you'll get x is going to equal, once again, 15 over 7, because if we were to take a 6 away from the top and a 6 away from the bottom, you'll get 15 over 7, noticing that x in the second portion and the x in the third portion both are represented by the same exact solution. I now know that the first portion is going to be the spot that is not going to be equivalent to the others. Great work, everybody. I hope you have a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you guys in the next one.